Jai Hind, my dear children. Today we could pass on to the next topic, electric potential energy difference and electric potential energy. Okay. So we can consider a charge Q here. What is that charge called? That is called a source charge. And consider 2 points A and B in the electric field of this source charge. And assume a test charge small q is placed at the point B. So what is there in between the source charge and this test charge? There is force of repulsion. So in order to move this test charge towards the point A, we have to do some work. Right. So once more, consider a source charge. Consider 2 points A and B in the electric field of the source charge, and consider test charge is at the point B. In order to move the test charge towards the point A, we have to do some work. Clear? So that work in bringing a test charge from one point to another in the electric field of the source charge against its force of repulsion is called electric potential energy difference. So we can write the definition later. First we can write a formula. So let the charge, this test charge is taken through a small distance dr. Okay, the charge is taken through a small distance dr. For that we have to do some work. The external agent has to do some work. So what is the small work in bringing the test charge through a small distance dr? Let the small work done, let it be dw. That small work done is, we know work is equal to force into displacement, isn't it? So F external into the displacement dr. And we know that the external force is opposite to the electrostatic force. So here electrostatic force are repulsion and external force are equal and opposite. Because the external force, the tendency of the external force is bringing the charge towards the point. And electrostatic force, the tendency of the electrostatic force is repulsion. Okay, so F external can be written as electrostatic Fe, but in the opposite direction, minus F electrostatic, or there is a Coulomb force, dot dr. Now, what is the total work to bring the test charge from the initial point B to final point A? So how will you find out the total work done? We can integrate. That is equal to integral the point B to A minus Fe dot dr. And we know that the force is equal to charge in the electric field. We have electrostatic force F equal to QE. Okay, F represents electrostatic force, a Coulomb force, E represents the electric field, and Q represents the test charge. Using that formula, we can write integral B to A, Fe can be written as QE. So minus QE dot dr. So this is the work done to bring a test charge from one point to another in the electric field of the source charge against its repulsive force. Okay, and hence this work done is called the electric potential energy difference, which is represented by delta E. So how will you define electric potential energy difference? Electric potential energy difference, it is a work done. It is a work done to bring a test charge. A test charge from one point to another in the electric field of the source charge against its force of repulsion. So this is called electrical potential energy difference. It is a work done to bring any charge from one point to another in the electric field of the source charge against its force of repulsion. Okay. Now, second topic is what is electric potential energy. So it is here difference. Here what is electric potential energy. So in the first topic we have studied what is potential difference and potential. Okay, similarly here also we can define what is electric potential energy. Here also we can consider the source charge. Consider the point A and let the initial point B is not here closer to the charge, it is at infinity. It is at a farther distance which is at infinity. And the test charge is at the point B. The test charge Q is at the point B which is at infinity. Here also, in order to move the test charge from the infinity to the point A, here also we have to do some work. Okay, that work in bringing the test charge from infinity to the point in the electric field of the source charge against its force of repulsion is called the electric potential energy. Okay, so here directly we can write what is the formula for electric potential energy. U equals integral which point to which point? Infinity to the point B. Sorry, in A, the point A is the final point, no? Infinity to the point A minus QE dot dr. That is the only change. Here one point to another, here it is infinity to the point minus QE into dot dr is called electric potential energy. So how will you define electric potential energy? Here it is the work done to bring a test charge from infinity to a point in the electric field of the source charge against its force of repulsion. This is called electric potential energy. So electric potential energy U equals integral infinity to A minus QE dot dr. Okay. And in the beginning of the chapter, we have defined what is potential difference and potential, electric potential. So potential difference means the work done to bring unipositive charge. Okay, instead of Q, if Q is equal to 1 coulomb, that is called potential difference. Here also, instead of Q, if charge is equal to 1 coulomb, it is the work done to bring unipositive charge from infinity to a point is called potential. Okay, so that is the difference. So energy, potential energy means we have to take any charge. Potential means we have to take unipositive charge either from infinity to the point or from one point to another. Right. Now we can write the relation between potential energy and potential. Okay, so we have the only change is in potential energy it is minus QE dot dr, potential energy difference. But potential difference is minus E dot dr. So what is the relation between potential energy difference and potential difference? That is delta U equals Q into delta V. Right. Similarly, what is the relation between potential energy and potential? Potential is minus E dot dr. Potential energy is, what is potential energy? Minus QE dot dr. So here also we can write the relation between potential energy and potential as U equals Q into V. So this is the direct relation between potential energy and potential. Right? Okay children, so hope you understood what is the main difference between potential energy and potential. Okay, thank you.